Okay, welcome back. So here I'm just going to work. I did example 6 in the last problem where we have to draw the freeboard diagram and then we'll find some two unknowns. In this example, I'm going to do example 6, and there's two problems, A and B. And we don't need to draw freeboard diagram. So the diagram given is like a freeboard diagram already, as you could see. Okay, in some problem you have to draw the freeboard diagrams. So let's look at the first one. So I'll do A and then I'll do B. So let me kind of zoom. Yeah. So we have two unknowns here. Not necessarily two unknowns, three unknowns. There's no numbers given. So if the force system shown in the figure is in equilibrium, determine theta and W. W might be like a weight. In terms of T, T will be like a tension. One is horizontal, one is diagonal. Okay. So if you look at the diagram very well, so as I say, it's always good to look. If you resolve in the vertical, you get T and W. But if you resolve in the horizontal, you're going to later realize that T can cancel out. So we can easily find theta. So let's do that. If you do summation of forces in the X equal to 0, and I'll put my semicolon here, we are not finding resultant here. So that's what this sentence means, sum of the forces in the X. So I'll have what those going this way is got those going that way. So let me write this way first. So this is the cosine part, and that will be the sine part. So I have 2t sine theta is equal to a t. So those pulling this side is got those pulling that side. Fortunately, the t and t cancels, and you can easily make theta, sine theta the separate, which is half. So theta is actually 30 degrees. If you do that, so very, very easy. Theta is 30 degrees. Therefore, if you go to, let me zoom out a bit. If you can go to sum of forces in the Y is equal to 0, then we can write W, which is coming down, and the only one that is going up is your 2t cosine theta. And we know what is theta, so it's 2t cosine 30 degrees. And this will end up to be right here. This is root 3 over 2, so this cancel. This is like t root 3. They didn't really give us any unit, so let's leave the answer this way. Yeah, so that is that. So we want to find theta as a number, but W is fine as that. Cool, very easy to work out. Let's look at the next one. The next one, we have numbers. So this is similar to the previous one, but this time, the previous one I worked, that is example 5. It was the example 5. It was the two tensions that were unknown. But here, look, one of the angles is missing. Here, the slope triangle is given. So the angle is unknown and the tension is unknown. The availability, a force, a tension. And they wanted to find those two unknowns. So it's kind of some simultaneous equation. Okay, so the way to solve this might be slightly different compared to example 5. But see the way I'm going to go about it. So once again, which one do you want to do first? Let's see which one can easily. If I resolve this here, it doesn't matter. We're going to have whatever we do, we're going to have T and theta, T and theta. So let's go for one. Summation of forces in the X equal to 0. It means I'm summing the forces in the X and they have to balance. So I'll get, for T, this is the cosine, that is the sine. For this one, the 8 is here, so this is 6, 8, and that is 10. So I'll get what? T, that is a cosine, so that is the sine. T sine theta is equal to, and this has no component in the horizontal, is equal to 80 times the slope triangle. The 8 is in this direction, is 8 over 10. Very easy, very easy. This end up T sine theta, 0 cancels 0, so that is 64, and that is equation 1. Then you go to summation of forces in the y equal to 0. And here we're going to take this and this half component going up equal to this. So let's do that. So I have t cosine theta at 80 times 6. You don't have to think. You don't have to think. If this 8 over 10 for this side, then the other side will be 6 over 10. And this is equal to 100. So I'm adding these two, the component of these two going up equal to the component coming down. Let me simplify a bit and make that the subject. So t cosine theta at 10 cancel that. I think 8 times 6 is 48. Yeah, equal to 100. So if you make t cosine theta the subject, I believe you're going to get 52. If there's any numbers, I'll do most of the thing from my head, and then I have a calculator here. So in case there's some error in terms of computation, let me know when you see me in class. Okay, cool. So here, look at this. We need to solve this simultaneously. And if some of you remember you can use your simple trigonometry to solve this. So I will show you a couple of ways of it. One way is to use tan, because one of them is sine, the other one is cosine. It does, yeah. So we divide the equation 1 by equation 2. So that I introduce tan. We divide left-hand side by left-hand side, and then right-hand side by right-hand side. So we're going to get what? T. We could have written tan directly, but maybe some people know this. So let's write this. So the left-hand side by left-hand side, right-hand side by right-hand side. So it look cool. It look cool now. So the t and t cancel, and then that is tan theta. And that is 64 over 52. Maybe we can simplify that, but it doesn't matter. Let me use my calculator here. It doesn't really matter to simplify it. That's 16 over, hold on, over 13. Okay. And then you do the inverse. Of course, here you have to possibly get the answer as decimal. And this is equal to shift 10. Hold on, I'm doing on my calculator, shift 10 of answer. That is like 50 point, let me write about 2 decimal. That's 50.91 degrees. And then you substitute your theta into either equation 1 or 2, any of them. You put in equation 1 or 2, and then you find that. Okay. So theta into 1, or somebody else can use 2. If you do, let me use 1 here. If you use then the t sign, 50.91 degrees, whatever it is, equal to 64. Let me check what I 64. Equal to 64. Then you just use the calculator. I have my 50.906 something. So I'll use down the calculator. So then this will end up to be 64 divided by sine the angle that I have on my calculator. Close it. Yes. And I'm getting this to be 82 point, let's say 46. Let's newtons. Okay, cool. So let me go back. Yeah, it's in newtons. Let me show another way of handling it. It's all about trigonometry. Let me show another way. So you just decide what you want to do. And of course, you could also substitute into. You could have also substitute into. There's a line here that I want to extend down. Let me draw this down. So I'm going to show another way of going about it. That is after method 2. After you've obtained t sine theta was equal to 64, that was equation 1. And t cosine theta equal to 52, that is equation 2. You could also make use of sine square plus cos square equal to 1. Okay. So you do equation 1 square, add equation 2 square. You could have also done that. That will give us t square sine square theta plus t square cosine square theta. And this is equal to 64 square. Whatever 64 square is, add 52 square, whatever it is. And then of course you factorize, let me check what is 64 square, add 52 square. So this is like 6800. And this will be your sine square theta plus cosine square theta. And we know that is 1. So you're getting t square equal to 6800. And then you do square root of this. So square root of this, of our answer, in set form, this one gives us nice set in exact form. Yeah. And in decimal, if you change it, we should get the same thing as 82.46 newtons. Then you substitute your t into 1 or 2 and find theta. That's interesting. Then you sub into 1 or 2, and then from there you can get theta. Okay, so you have 2 approaches, any of them. So I've shown you a couple of ways after the equation has been set up. Sometimes 2 tensions of 2 forces. You just do elimination or substitution, very easy. Sometimes it's an angle and a force. Then I'll show you. You just make sine theta the subject, cosine theta the subject, something like that. And then introduce tan, or use sine square plus cosine square equal to 1, and then you can easily solve. So I've able to solve example. I've done it example 6 for you. There are 2 listing A and B, example 6 A and B, and then you can, if you have a question, you can ask. I'll do the next examples maybe soon or later on. Okay, all right.